Okay. So after completing the fixed wing and the rotorcraft, we are moving to the hybrid operations and aerodynamics. Okay. In this, we'll see how the hybrid drones. What are the principles of aerodynamics? Does it follow? Then types of hybrid drones and parts, and then application of hybrid UAVs, where actually the hybrid UAVs are used. Okay, where we can utilize them for what kind of projects or what kind of applications. Okay, so again, since it's similar to your aeroplane, and as well as it also has the feature of like a rotorcraft also. So here again, those same four forces acting on the drone, that is the lift, weight, thrust, and the drag. So can you explain when the aircraft is in the air, how these three forces are acting, or how these four forces are being import on the aeroplane.
Yes, the weight is itself weight of the aircraft.
Correct,
Then the thrust is thrust generated by the engines.
correct.
Then
to
the
move forward.
then the drag is the friction created by the atmospheric air,
On the
and
body.
and the lift is generated by the wings.
Correct. So lift is generated because of the difference in the pressure
Pressure.
on the wings. Okay.
Yes.
So you are clear on this. So airflow changes, and pressure distribution over the airfoil. Okay.
Yeah.
Let's see now again the same thing. You see here there is a leading edge, and then you have a trailing edge over here. Okay. So this actually covers similar to your aircraft, because the shape of the drone is shape of the aeroplane is similar to the hybrid drone also. Okay, not nothing different. It is only additional. It is that it doesn't require uh, a runway. Okay, because even it has similar to your what we say similar to your rotorcraft, it also has the four propellers, which will actually help to go into the air. Okay. So important is the chord line, because chord line is with relative to the wind, it creates the angle of attack. Okay, which helps it to go further or pitch up in the air during the takeoff, or even during when it is transitioning from the rotorcraft drone to the aeroplane drone. Okay, so again, the same terminology what we have learned in the basic principles of the flight, or during the fixed wing operations and aerodynamics. So leading edge is the part of the airfoil that hits the air particle first. Trailing is the part of the airfoil that hits the air particle last. Chord line is a straight line joining the leading and the trailing edge of the airfoil. Chord is the distance between the leading and trailing edge measured along the chord line. Lower surface is the surface of the airfoil following the leading and a trailing edge on the lower surface. Upper surface is the surface of an airfoil between leading edge and trailing edge on the upper side or upper surface. Mean camber line is the line joining the leading edge and trailing edge of airfoil equidistant from the upper and lower. Okay, so if you see here, the chord line will be the curvature. Okay, whereas the chord line is the straight line. Sorry, chord line is the straight line. Camber line is the curvature. So it is equidistant from the upper surface as well as from the lower surface. So normally your camber line will always take the shape of the airfoil. Okay, mean camber line is the line joining the leading and the trailing edge of the airfoil, equidistant from the upper and the lower surface. Whereas the maximum camber is the maximum distance of the mean camber line from the chord line, and the this is supposed to be a thickness. Okay, so maximum thickness is the maximum distance of the lower surface from the upper surface. That means this distance. Okay, this is the distance what we're talking. Whereas the distance between the chord line and the mean camber line is your maximum camber. Okay, how much camber is the maximum distance between the camber line from the chord line. Whereas the thickness is the maximum distance of a lower surface from the upper surface. So this is the thickness. When we measure the thickness of the wing, wherever we are, like here, if we measure, it will be less. Here we measure, it will be less. But if we measure somewhere here, it will be the highest. Okay. The distance between the upper surface and the lower surface is the thickness of your airfoil. Now again, when we talk about the forces acting on the hybrid drone, since it is similar to the aeroplane, we said the lift is the force that holds the drone in the air. The wing creates most of the lift used by the airplane. Weight is nothing but the force caused by the gravity. Okay. Thrust is the force that moves an aircraft in a direction of the motion. It is created with the propeller, jet engine, or rocket. Air is pulled in and then pushed out in the opposite direction. One example, like, could be household fan. Drag is nothing but drag is the force that acts opposite to the direction of the motion. So as we see that the aeroplane is moving forward, so there will be always a drag will be imported on the body of the aeroplane. It tends to slow an object. Drag is caused by the friction and the differences in the air pressure. An example is like putting your hand out of the moving car window or feeling it pull back. So this is example yesterday also I explained, right? When you put a hand outside the car, bus, or even a train, you'll always feel that your hand goes on the back side or it's pulled back, kind of thing. So that's what your hand has a surface, and as we are moving in a forward direction, the air which is hitting our hand will tend to put our hand backwards or pull backwards. Upper streamline, high velocity, low pressure. Because of the low velocity, high velocity below the wing. So the difference in these two pressures, low pressure and high pressure, surrounding the wing will create a lift. Okay, the longer path is transition. So both air particles, upper and low, has to travel and reach the tip, or what we call as the thin edge of the wing time. So that's why we see that due to high velocity there is a low pressure created, and due to low velocity high pressure is created below the wing. Okay, so difference in the pressure produces the lift. So remember this difference in the pressure. So on top it is low pressure, below it is high pressure. So this, whenever somebody asks you about the Bernoulli principle, you should be able to tell this definition very clear. Okay, now let's see what are the parts. So as we said, hybrid drone is similar to your aeroplane, but it has an additional feature where four propellers with respect to the rotorcraft are also attached to the body. So if you remove these four propellers, it is an aeroplane only. Okay, but then it requires a landing gear, probably a wheel and all that, so that it can run on the runway and then it can take off. But to avoid that runway part and all the things, they have attached four propellers so that rather getting on a runway, from the particular location, it can just simply vertically take off the drone. So you have four wings or four rotorcraft. You have wings. You have on the wings. You have ailerons. Then you have horizontal stabilizer with elevators, and then you have vertical stabilizer with radar, okay, or vertical tail, what we call it. Then you have four rotors, which are actually called as lifting motors, or they are cooler motors, kind of thing, so which will take your drone up in the sky. But there is a fifth motor. Once it transitions from a drone, once it has done the VTOL action, vertical takeoff action is that it will transition from a normal drone to a aeroplane mode. So when it transitions from normal drone to aeroplane mode, it has to move forward. So this pusher motor will start. Okay. So this is the fifth motor, which is a pusher motor. Since it is a backside of the fuselage or on the tail section of the aeroplane, that's why it is called pusher motor. If the same motor is in the front, okay, then it is called as a puller motor. Okay, so it could be rotating in the front. So normally, most of the time, just to aerodynamically to and stabilize the plane, most of the time you will see the hybrid drones have the motor at the backside of the fuselage to stabilize and have the weight balanced out properly. So let's see what is the difference. Now here you have a drone where you do not have a separate motor to perform the forward motion. Here the same motors get tilted. So when it is on the ground, if you see here, when it is on the ground, the motors are pointing upwards in the sky direction. So it will take off. As it goes up in the sky, the motors start tilting. Okay, and then they will become completely horizontal. Okay, and once it is in, it has transition from the normal drone to the aircraft. The motors will continue to move, and then they will give you the forward thrust. Okay, once it is giving a forward thrust, it will continue its operation until unless when it requires to transition from aircraft to the normal drone. So again, the motors will tilt and become vertical, and then that drone will vertically land on the ground. This is how the configuration of hybrid drones are there. There are some drones where your motors can tilt, but if in case the motors are not in tilt position, then you have to add the fifth motor, which will help you to transition from normal drone to the aircraft and then perform the forward thrust with the fifth motor. Okay, that when the fifth motor is running, your other four motors will stop functioning or will stop running. Okay, that's how you save the battery time and you will have a more endurance capacity or flying capacity with only single motor working. And since the drone can glide, so it will be not utilizing much of the power from the battery. That is the advantage of the hybrid drone. So there are different types of hybrid drones, like you can see here as per the images, what we can see. This orange colored drone is very famous and very widely used as a hybrid drone because you see it is just having two motors. That's it. So as it goes up in the sky, so only these two motors are there. As it flies up in the sky, and then it transitions from a normal drone to aeroplane mode, and then it performs the surveillance activity. So this is more or less used in surveillance and mapping kind of drone. It's very famous and very stable drone. I have seen the operations of this drone also. Uh, right now, I think they have come up with a newer version. This was V1. I think now they have come with V2 version, and which is more stable, and it also has a lidar capacity built into it, so that you can capture the lidar related data also using Wing. Whereas if you see this particular drone, this drone also has two motors. Okay, so when it is vertically take off, it will these two motors will actually take off, and then this motor will change its angle. Okay, so from vertical position, it will change it to horizontal position, and then it will perform the functions of a aircraft. So that's how these drones are being created. So there are very innovative designs also are coming up in hybrid drones, but most importantly is the transition phase and the stabilization flight of what is required when these hybrid drones are flown in the air. So what are the applications of hybrid VTOLs? The hybrid VTOLs are used in operation where terrain is difficult to land or a fixed wing airplane, but endurance needed is more than the multi-rotor. Okay. So when the terrain is difficult means what, you can't have a runway kind of thing, or you can't have a location where you can take off or land, kind of thing. Like for example, let's say you want to do such kind of activity in coffee plantation kind of locations where mostly they are slopy kind of terrains are there, or like Assam, hai, Kerala, hai, all that locations, where you see mountainous terrain is there, and it's very difficult to have any kind of a landing or takeoff runway for your activity. So in that scenario, you will always use hybrid VTOL. Okay, so it can vertically take off, perform its functions, and then again land it as a drone or a vertical landing it can do. So primarily, these hybrid VTOLs are used for large area mapping. So most of the time, we have seen hybrid drones or hybrid VTOLs are used for activity where surveillance or mapping is required. It is used to transport heavy payloads over large distance with hilly terrains. Okay? So mostly in hilly areas only these hybrid VTOLs have come into the usage. That's what we have seen. It also helped during the search and rescue operations in these hilly terrains and other things. Again, it is used for cargo deliveries also. Okay. So with that, we complete our hybrid operations and aerodynamics. So, do you have any questions?
No, sir.
Now, have you understood now the difference between the three, the fixed wing, the rotorcraft, and hybrid, right?
Yes, yes.
Yes, sir.
With this, actually, we cover the day one part of the training.
Sir,
Hmm.
uh, but in costing wise, hybrid is, I think, more costly, right?
Yes, yes, of course, because it is also performing like a normal drone, as well as it is also performing your
Fixed,
actions,
fixed wing.
actions. But only advantage is that you don't need a runway for this. So with that scenario, it is advantageous, and it is a very advantageous when you are flying your drone in a hilly areas or a terrain kind of areas where you cannot construct a runway or you can't have a runway at that
Okay, okay.
Yes, sir.
place. Just give me 2 minutes. Okay. So now our next topic is what? Okay. So, so we have completed stakeholder basic principles, ATC procedures, fixed wing, rotorcraft, and hybrid. So